Electric kettles and toasters. How does the simple nichrome element heat water so quickly? Nichrome heating element. Electric kettles and toasters are examples of high-wattage appliances designed for speed. They rely on the same fundamental principle as the electric iron, Joule's law of heating, but are engineered to deliver intense, focused heat instantly. The secret to their rapid function lies in the properties of the nichrome heating element and the high power they draw. The power draw, high current, high heat. The primary reason these small appliances heat so quickly is their high electrical power rating. A typical domestic kettle or toaster draws between 1200 W and 2000 watts. According to the power formula, P is equal to 6, power is equal to voltage * current. A high power rating means the appliance draws a very high current, I, from the wall socket. As the heat generated is proportional to the square of the current, H proportional to I2, a slight increase in current leads to a massive increase in heat production. Nichrome, the ideal resistor. The material of choice for the heating element is almost universally nichrome, an alloy of nickel and chromium. This alloy possesses three critical properties that make it ideal for quick heating. High resistivity, R. Nichrome strongly resists the flow of electrons, forcing more energy to be dissipated as heat. High melting point. It can glow red hot, up to 1400 Celsius or more, without melting, ensuring appliance longevity. Low oxidation rate. It does not readily rust or break down, even when exposed to air, in a toaster, or water, in a kettle, prolonging its life. Function in an electric kettle. In an electric kettle, the heating element is fully submerged beneath the water, or it is embedded in a flat base plate, often preferred today for safety and easy cleaning. Submerged element. The element is directly in contact with the water, allowing for near instantaneous and highly efficient heat transfer by conduction. Base plate element. The element is sealed beneath a stainless steel plate. Heat is conducted through the metal base and then transferred to the water. This design reduces mineral scale buildup on the element itself. Boiling point cutoff. Kettles use a steam sensor switch that automatically turns the kettle off once the water boils. The escaping steam travels up a channel to the switch, causing a bimetallic strip or similar mechanism to trip the power. Function in a toaster. Toasters use the same nichrome wire, but coiled tightly and mounted within a chamber. Radiant heat transfer. Unlike the kettle, where heat is transferred primarily by convection, the toaster relies on thermal radiation. The coiled nichrome wires heat up until they glow red hot. Infrared rays. These glowing coils emit infrared radiation, which penetrates the bread, causing the water inside to evaporate and the starch molecules on the surface to undergo the Maillard reaction, browning, resulting in toast. Timing mechanism. The toaster uses a timer or a bimetal strip release connected to a solenoid to automatically lift and switch off the bread after a set duration, preventing burning. Summary. Electric kettles and toasters achieve rapid heating through a combination of drawing a high electrical current and utilizing the inherent high resistance of the nichrome heating element. The efficient transfer of this intense heat, either through direct conduction in a kettle or radiation in a toaster, makes them ideal for quick kitchen tasks.